This is video 2 from Unit 5, Lesson 1. We're still going to be solving systems of linear equations with graphing. This time, though, we're going to be graphing equations that are in standard form instead of slope-intercept. Okay, so let's just review how to graph an equation in standard form. We're going to use x and y intercepts. You can put this in slope-intercept form if you like to do it that way, but usually these are easy enough to just put in, to keep it in standard form, but find x and y intercepts. Alright, so if we want to find, remember the x-intercept, we're plugging in 0 for y, which means we can cover this part up, because negative 2 times 0 will just be 0. So you get 4x equals 16 divided by 4, so the x-intercept is 4, 0. And then when you want to find the y-intercept, you plug in 0 for x, so you can cover that term up. So negative 2y equals 16 divided by negative 2, y would be negative 8. Okay, so my x-intercept is 4, 0, so on the x-axis. And then my y-intercept is 0, negative 8, so on the y. 4, 5, and 8. And then I connect those with a line. Okay, so when I solve systems, I will have two equations, and I'm still going to be looking for where they intersect. But this was just to review how to graph them in standard form. Okay, so both of these are in standard form. So you need to find x and y intercepts of both equations. So if I do this first one, I need this intercept table, so plug 0 in for y. So you get 9x equals negative 9. So x is negative 1. So that's my x-intercept. Okay. And then for my y-intercept, cover up the x. So same thing, 9y equals negative 9, so y is also negative 1. Okay, so your x-intercept is negative 1, 0. Your y-intercept is 0, negative 1. And then we'll draw a line through those. Give me a chance to fix this line. And then in the second one, we do the exact same way. Okay. It is important to have these lines accurate. Okay. So now for this equation, alright. So you get ax equals negative 20. Okay, so it's okay to get a decimal. I mean, they're a little bit harder to graph, but this one won't be too bad because you get negative 2.5. Okay. And when you want to find the y-intercept, cover up x. Y equals 5. Okay, so 0, 5. And negative 2.5. So just the best that you can, halfway between negative 2 and 3. And then we'll connect those Okay. So I think this line is off just a bit. Like I said, they should go through a point. And it's going to be, sometimes you're going to have to just pick the closest one because your lines may be a little bit off. It's going to be right here. And that's -2, 1. And you can always check that that's right by plugging it back in. So 9 times -2 plus 9 times 1, does that equal -9? Yep, so we're good there. And then 8 times -2 plus 4 times 1, or minus 4 times 1, does equal -20. Okay, so this point was correct. So pause and try the next one, and then check to see that you did it right. So for the first line, so if I plug in 0 for y, I have 3x equals 30, so my x-intercept is 10. If I plug in 0 for x, -5y equals 30, so that's -6. Okay, so 10, 0, and 0, -6. Okay, and now let's look at the second one. All right, so cover up y, and we get 12.5, which is a little bit off our graph, so we'll just have to kind of estimate where that is. Makes this a little bit harder. Just do our best there. And then I think you get -5. 15y equals -75. -5. Okay. And it's a little bit hard to tell, but your lines are probably a little bit off, so you know, if you need to just pick one of these points and then check to see that it's right, we'll do that. And it actually should be right here. Oh, wait, I think it's actually going to be here. It'll be a little bit easier to tell on the ones on your homework and test. The answer is 5, -3. Again, that was a little bit hard to tell on the graph, but I think your graphs are a little bit more accurate than mine since you're just using a paper and pencil and I'm using this computer program. And like I said, it won't be things like 12.5, or you could adjust your scale so it's a little bit easier. Okay, we do need to consider no solution and infinitely many solutions. So in the last video on our steps, we talked about when we graphed, there would be no solution if the lines were parallel. Well, I can tell these lines are parallel because they have the same slope, but I'll graph them real quick. So -4 is where I start, the first line, then up 1, right 3. Okay. And then up 6 for my second line, up 1, right 3. Okay, so parallel lines never intersect. So if they never intersect, then they don't have that point of intersection, which is their solution. So this one, we would just write no solution. So instead of an ordered pair, we'd write no solution. Okay, infinitely many solutions. So let's see what those look like. So the first one I can graph, because it's just in slope-intercept form. 4, 5, 6. So start at 6, go down 1, right 2. But also up 1, left 2. Okay. Then we want to find our x and y intercepts of the second line. So this will be 12 and this would be 6. So 12, 0 would be about right here, and then right here. And as you can see, so like if I were to extend to this line, they're the same exact line. So since they're the same line, they lie on top of each other, which means that they have infinitely many solutions because they have infinitely many points of intersection. Okay, we're ready to do assignment 2 from Unit 5.